Hello everyone, I am Pradeep Bhavne, Assistant Professor, Shri Vileparle Kelvani Mandas, Institute of Pharmacy, Dhule. Today we are going to discuss about designing of aseptic area. Disclaimer, please note that this presentation is solely made for education purpose only without any commercial interest. The intention of the presentation is to explain design of aseptic area. The information provided in this presentation by the author is taken from his own personal experience and the references quoted at the end of presentation. Learning objective. After completion of the session, students should be able to first describe aseptic area with respect to design, construction and facility. Second, draw a flow diagram of aseptic area. And third, explain aseptic area with its applications. Definition. Aseptic area is a room within a clean room designed, constructed, serviced and used with intention of preventing microbial contamination of the product. It is used to control contamination into ophthalmic and parenteral products. The control of contamination is necessary to eliminate pyrogens and toxic bacterial products. Terminally sterile products like those which are generally sealed in the container and finally getting sterilized are prepared in the clean room, and non-terminally sterilized products which are aseptically prepared for, from the sterile material and filtered before being finally packed in sterile container. So for manufacturing of such a product, we need to use aseptic area. Like for example, vaccine consisting of a dead microorganism, microbial extract, or inactivated viruses may be also filled in aseptic area. Aseptic area is used to minimize the exposure of sterile article to potential hazards of contamination during manufacturing process. Now, in aseptic area, how we are going to achieve the minimum contamination? By adopting good environmental control process, we can adapt process flow optimization wherein we are trying to set the desired flow of material as well as personnel. Good designing of equipments to prevent low quality air in critical area by employing air handling unit and HEPA filters. Fifth, optimize personnel and material flow. So we are designing the process for the personnel as well as the material flow so as to minimize the cross flow of a material and personnel, which will avoid the contamination. Well designed, maintained and operated aseptic procedure has to be adopted in aseptic areas so as to minimize the contamination. And finally, personnel which are working in the aseptic area has to be trained for the aseptic technique so that they should be able to handle aseptically these equipments. Production areas can be divided into the different sort of area, like for example cleanup area, then compounding area, aseptic filling area, sterilization area, quarantine area, packaging and finishing area, quality control area, and finally storage and shipping area. Now we will see the design and construction with the help of a flow diagram of aseptic area. So it is equipped with a airlock with a double door entry and interlocking system so that when the person enters in the production area, it has to be first open the door, and then uh, while he enters, the second door will remain closed. And once he want to open the second door will open only when the first door is closed. So interlocking or airlock system has been employed in the production area. If you see the flow of material and personnel, the arrows which are indicating the flow of material and personnel in the different production area. So the office personnel first has to enter into the stock room, and then cleanup room. Cleanup room is equipped with the cleaning aid, wherein you have to own the aseptic sterilized clothing which has been kept in the UV cabinet, and then you have to enter into the rest of the areas. Like for example, you can enter into the compounding area where the weighing and compounding of a material can be taking place. And when if you consider the compounding area, this compounding area is quite different than that of the aseptic area. It is not means provided with that much of a control as compared to the aseptic area. But in compounding area also we have to take care that we have to minimize the dust production. Then next one is the aseptic and filling area, wherein we are going to adapt all the precautionary measure and air handling unit. We have to control this area with respect to the airflow, temperature, humidity, and rest all the parameters which may be responsible for causing contamination. Then you can see this double arrow which is indicating the flow of material, and the personnel can be in a two-way manner. So person can enter from compounding area directly to the sterilization area, or sterilization area to the compounding area. Then from cleanup area also the personnel or material can be transferred to the sterilization area. And you can see over here the from the sterilization area, whatever the sterile material may be there, that can be transferred into the aseptic filling area. Or if you are carrying out any operation under the aseptic condition, even though if you want to sterilize it finally after packaging, you can move to the sterilization area. The next one is a quarantine area, wherein we are keeping the product which are in process as well as the finished product. From the sterilization area, we can move to the quarantine area. Those products which are generally first filled and then sterilized, that can move from sterilization area to the quarantine area. And from the sterilization area also, the product can be moved to the packaging and finishing area. And finally, we can see over here uh, packaging area and finished product area. This product from this area also can be shifted to the quarantine area, and finally it can reach to the storage and shipping area after the quality control of a product. So once the quality control department approves the release of a batch, this batch will be shifted to the storage and shipping area, from where it will be dispatched for the market. Then we will see design and construction. It is a room with flawless control over the particulate contaminants and classified as per the number of particles present per cubic meter. It is constructed with a highest standard in accordance to control humidity, temperature, and pressure to minimize generation, introduction, and intention of particulate matters inside the room. It is used for manufacturing of sterile formulation and separated from general manufacturing area. These rooms are fitted with HEPA filter and dehumidifier to create moisture and microbial free environment. First of all, we will discuss about the cleanup section. The cleaning area has wall and ceiling made up of a film coated material. Second, this is ensured through high efficiency filter. Even though we are not employing that much amount of a air handling unit as we are using in case of a aseptic area, but still this area is also under control. The air inside the clean area should be free from dust and microorganisms, and air existing in the clean area should be frequently replaced. Then we will move to the compounding section. This area contains stainless steel cabinet and counter is involved in the actual compounding. Unlike aseptic area, maintenance of sterile condition is not essential in the compounding area, but still we have to take necessary measures that has to be taken or adopted to control the dust generated from raw material during weighing and compounding. Then the most important area, that is aseptic area. In this area, strict control measures should be adopted to avoid contamination of the operation. The stainless steel counter and cabinet should be such that they should not allow dust particle to accumulate. Mixing and storage of the compounded preparation should be done outside the aseptic area And last, the compounded preparation are then transferred to the aseptic area through pipelines where the filling operation is carried out. Then we will move to the quarantine section. This area consists of a store wherein uh, in process batches as well as the approved batches are stored separately and labeled properly. This area is having a limited access and it is under control of a responsible person. So without a consent of a in charge, other personnel cannot enter in this particular area called as quarantine area. Then move to the packaging and labeling section. In this area, the batches are packed and labeled. Packing is carried out by the packaging machine, while the label is obtained by overprinting devices. At a time, only one product label are printed so as to avoid inconvenience and uh, the chances of mistake. Then parental packing plays a vital role in production of a sterile preparation. Packaging should be carried out in such a manner that the sterility of a product is maintained. Then we will discuss about floors, walls, and ceiling points to be remembered. First, whatever the walls, floors which has been constructed, the surfaces of this area should be smooth, easy to clean, and easy for disinfection purpose. Second point has to remember it is constructed to minimize the particulate matter and microorganisms. So whenever we are dealing with the formulation which has to be prepared under aseptic area, we are not having concern only about the microorganism, but also we have to take care that the minimize particulate matter. Then for the purpose of construction of a floor, we are generally using two kind of a material. Flexing and non-flexing materials are used for the construction of floors. We will quote certain examples for the flexing materials or the flexing floors, for which we are generally using synthetic elastomers like polyvinyl chloride, PVC we called it as. It is also easily been repaired, cleaned and relatively cheap and simple. Then certain non-flexing floors, hard inorganic filler substances in the matrix material we are generally using for the purpose of construction of a non-flexing floor. When we are using concrete, it is generally used along with certain adequately sealed material or material which are generally resistant to chemical, solvent and cleaning fluids. Then few more points with related to floors, wall and ceiling. Wall must be made up of a non-flammable or fire-resistant material. Example: stainless steel, glass, enamel steel, etc. Then generally plasters wall are easily been damaged by the impact, and that is why we are not using a plaster wall. Okay. Instead of that, we are generally using a different kind of a, color, that is epoxy coating we are going to use. For the reduction of a fungal growth, 1% of 8-hydroxyquinone, pentachlorophenol, etc. may be added to the paint. So that will reduce the fungal growth over the surface of a wall. Then epoxy resin paint and polyurethane paints are also can be used to avoid cracking and peeling. The ceiling are sealed to prevent the entry of microbial contaminants. And finally, internal fittings such as cupboards, drawers, shelves, and equipment must be kept to the minimum. Along with that, whatever the walls we are creating, it should be free from the corners, because there may be a chances of accumulation of a dust in the corners. Even though whatever the ceilings we are using, that should have the fit flush type of a fitting, and that should not have a sharp corners so as to avoid the accumulation of a dust. Doors, windows and services. Doors and windows should be fit flush with the walls so that there should be no crevices present and there will be no accumulation of the dust can be there. And windows, if required, are solely provided for the purpose of illumination only and not for the ventilation strictly. And windows should be non-openable. Doors should be well fitted by maintaining the positive pressure airflow, and self-closing doors are generally employed. Door must be limited in number. All pipes uh, passing through the walls of the rooms should be effectively sealed and should be flush fitting in and easy to clean. This particular thing has to be remembered. If we are using a pipe which has not a flush fitting, then what will happen? It can accumulate the dust over the surface, and that is why that may be creating a chance for causing a contamination in the product during the manufacturing. Then gas cylinder should be excluded and all gases should be piped from the outside area. Sink and drain must be excluded from the areas where aseptic procedure are performed in clean room areas. Light sources are fitted with the ceiling to reduce the collection of dust and to avoid disturbances of the airflow pattern. Non-essential switches such as room lighting switches should be installed outside the clean area. Then personal and protective clothing. The main source of contamination of clean areas arise from the skin scales which are released by the operator. So while selecting the personnel itself, we have to take in care that whatever the we have to see whether the person is having any sort of a skin infection, okay, which may leads to the formation of a skin scale, and that may act as a source of contamination. So while selection of a personnel only, we have to check these measures. Second, personnel selected to work on a preparation of the parental product must be neat and reliable. Okay, he should be having adequately trained to handle the equipments in the aseptic areas. They should be good. They should be in a good health and free from dermatological condition that might increase the microbial load. As I told, while selection process only, we have to check whether the person is having any sort of allergic diseases, whether he is having any sort of dermatological conditions. Okay, so such personals are not selected to work within the aseptic areas. Then operator-borne contamination can be controlled by limiting the number of operators in the clean area. So we have to minimize the persons which are working within the aseptic area so as to avoid the contamination, chances of contamination within the area. All personnel should be trained for the good manufacturing practices and aseptic techniques. So how to handle the material within the aseptic areas, how to fill the material within the aseptic areas, what are the different equipments to be used in the aseptic areas. The persons who are working in that particular area should knows this particular thing very well, and that is why the personnel has to give the training, okay, for the good manufacturing practices and aseptic handling. Then we will move to the personal and protective clothing. The operator should wear a sterile protective clothing including headwear, powder-free rubber or plastic gloves, and a non-fiber shading face mask and footwear. Let me tell you what will happen if we are wearing a gloves which are having a powder. Usually if you see the surgical gloves which is having a powder, okay, now when you are performing your function within the aseptic area, what will happen? This powder may be generally suspend in the air, and that may be also act as a source of contamination. So such a type of a gloves are also not recommended in the aseptic areas. Then non-fiber shading face masks and footwears also has to be used uh, very precautious by taking a very minute precautions, like for example, if you are using the face masks which can able to shed certain threads, and that threads can be generally suspended in the air, and that can also act as a source of contamination. As well as whatever the footwears we are using, that has to be covered with the help of a foot covers. Okay. All protective clothing is designed to prevent the contamination from the body. So whatever the skin scale formation may be there, okay, or whatever the dead tissues which may be getting chances of getting suspended in the air, that has to be protected by the means of wearing the protective clothing when you are working under the aseptic areas. All protective clothing must be sterilized by moisture sterilization or ethylene oxide sterilization method, so that it should be free from contamination. Fresh sterile clothing should be normally be provided each time the person enters the aseptic area. So as many times you are entering inside the aseptic area, you have to wear the fresh sterile clothing, and then only you should be allowed to enter inside the aseptic area. Then cleaning and disinfection. Cleaning and disinfection procedure are used for the removal of microbial and particulate contamination. Cleaning agents are alkaline detergent, non-ionic, ionic surfactant we can use. Different type of a disinfectant should be employed in rotation to prevent the development of a resistant strain of a microorganism. Like for example, if we are using a same single type of a disinfectant again and again, there is a chances of development of a resistance by the microorganism, and that is why we have to use the disinfectant in the rotation manner so that we can avoid the creation of a resistance by the microbial strain. Then different concentration of quaternary ammonium compound, sodium hypochlorite, ethanol, and formaldehyde solution are certain examples of a disinfectant which can be used in the cleaning area. Then we can go for also cetrimide or chlorhexidine in 70% alcohol, which are generally considered to be the suitable for use as a skin disinfectant. So whenever you are entering inside the aseptic area, prior to that, you should sterilize your hands, sterilize whatever the open skin area may be there with the help of either cetrimide or the chlorhexidine, which is prepared in 70% alcohol. So this cares has to be taken when you are performing the function in any sort of aseptic area. Then finally, we will move to the air supply. The air supply to the clean room must be filtered through the high efficiency particulate air filter, that is what called as HEPA filter, which is normally having the filter size which may come 0.45 micron and which can able to retain all sort of bacteria. The HEPA filter must be positioned at the inlet of clean room, and a pre-filter may be fitted upstream of the HEPA filter to prolong the life of final filter. So always whenever we are using the HEPA filter, we have to use the pre-filter so as to increase the life of a HEPA filter. HEPA filters are used in construction of vertical and horizontal laminar airflow, which is generally used in the aseptic area. The air filtered from the laminar airflow is claimed to be 99.97% free from microbial contamination. These filters are supported to provide class 100 air, and they should be certified every 6 to 12 months. Okay, so class 100, you might be having portion over here. What may be the class 100? So the area which does not have particles more than 100 per cubic feet. Okay, that is considered as a class 100 area. Air quantity is evaluated using settle plate, microbeer air sampler, and biparticle counter. So this validation has to be carried out again and again, and every 6 to 12 months we have to carry out the validation for the laminar airflow, whether the laminar airflow is efficient in retaining the bacteria or not. References. Thank you very much for your patient listening. Thank you.